looking at, say, the tilt in Chicago or something like that, and you're wondering, well, how long does it take for something to fall down? The other day we solved problems like this, and we figured out that the distance that an object falls is proportional to the square of time times this constant, which is 16. Now, in our case, the case of that skywalk here, the sky deck, you're 1,353 feet above the city floor. So a question could be, how long does it take to fall 1,353 feet? So we need to solve for t. Now, a good first place to start in solving for t would be to divide both sides by 16. But now we come upon this problem where we've got t squared. I don't want t squared, I want t. So what's the opposite operation of squaring? Square root. Good. So what you can do is take the square root on both sides. Of course, mathematically, when you're solving an equation, the trick is to always do the same thing on both sides of the equation. And that thing is to take the square root. So what you end up with, square root of 1,353 over, it's going to be like 8 something seconds maybe? I don't know, 8, close to 9 seconds. Let's find out. So you hit the second key, then the square root key, 1,353 divided by 16, and then I got the square root of all that. Yeah, about 9.2 seconds. So great, great. Now, that's kind of bringing us to where we want to look at things today, which is working with square roots. Now let's start with kind of an easy one. One for which we don't need to take out a calculator, square root of 16. All right, come on, without a calculator, somebody, 4, yeah. Now, what you're looking for is a number that you can square to get 16. And I could, if I wanted to, say, well, you know what? -4 times -4 would also be 16. But to kind of keep things straight here for ourselves, if I want the positive value, I'll just have a positive out here. If I want the negative value, I'll have a negative out here. And occasionally you'll see me asking for both. I'll do the plus or minus, and then the answer I'm looking for is plus or minus 4. So it kind of depends on what you've got as to what your answer is going to be, but more often than not, you're going to be looking for the positive root. And if you want a fancy term for that, it's also called the principal square root. How about this? What if I did square root of -16?
4.
Well, all right, so a 4, but 4 times 4 is positive 16, so it doesn't give me back what I started with. I could try -4, but -4 times -4 is again positive 16. So what we say about this is that it's not a real number. And in my class, I like to abbreviate it as NARN. For reasons lost to me, this hasn't caught on with the wider math world. If you say NARN to somebody outside of this class, they'll probably look at you strange. But inside this class, it's a nice, healthy acronym for not a real number. Now, it's not to say that we can't do anything with this. We will. But for right now, it's just not a real number. Let me do a couple more of these warm-up examples and then move on. Let's take a look at the square root of 9 over 16. Now, a lot of you probably be unhappy to work with a fraction, but there's a cool thing about working with fractions and radicals. When you're dividing or multiplying with radicals, you can split those up. I can call that the square root of 9 over the square root of 16. And then work with each of these individually.
3 over 4.
Perfect, 3 over 4. And how could you check it? If you're like, that doesn't look right.
Multiply by itself.
Yeah, if you multiply it by itself, 3 over 4 squared, which is 3 over 4 times 3 over 4 or 9 over 16. It checks. So what you thought is what it is. 3/4. Cool. Now, a lot of you probably would just take out your calculators to do this one, and that's fine. Square root of 0.09. Take out your calculators, take a moment to find that square root key. If you need to borrow a calculator, you know the price of admission is a phone or a set of keys, but I got a few calculators up here. You're going to want one around for this section. File backwards. Come on. All right. There you go. There you go. So you should be getting 0.03, but there's other ways to get this. Just checking to make sure there's charge. Okay, so off your calculator, you should be able to find the buttons and get 0.3. If you've got a TI-84 or similar, TI-83s work as well, then you're just going to hit the second key, the x squared key, 0.09, and it should give me 0.3. Wonderful. But let's take a look at it a different way. That 9 is in the hundredths place, so I could also think of this as 9 100ths. And from there, let's break it up as the square root of 9 over the square root of 100.
3 over 10.
3 over 10. Thank you so much. So that 3 over 10 is exactly the same as 0.3. So kind of a different way to think of that. Now, I've taken the time to show you that you can split things up with division. You can also do it with multiplication. But let's take a moment and think about addition and subtraction. Can we split things up amongst addition and subtraction? And whew, for a second, I thought I was out of paper here. So the question is, square root of a plus b, does it equal the square root of a plus the square root of b? Okay, let's find out. In a similar way, we can look at square root of a minus b. Does that equal the square root of a minus the square root of b? Well, let's try this example. Let's try the square root of 144 plus 25. Does anyone remember what the number 144 is called? I mentioned that in class a week or so ago. It's a gross. 1 dozen, 12 times 12. So the question is, if I split this up, do I get the same thing both ways? Well, on the left-hand side, I get the square root of 169, and you might think, oh, well, he didn't choose that one by accident. Yeah, that's 13. Well, how about on the right-hand side?
It's 12.
12 plus 5 is 17, and yeah, those don't look like they're equal, do they? How about over here with subtraction? So let's do, for instance, square root of 25 minus 16. Is that equal to the square root of 25 minus the square root of 16? Well, on the left-hand side, I get the square root of 9. On the right-hand side, I get what?
5 minus 4.
5 minus 4. Yeah, I'm striking out. Neither of these work. As much as you might like it, you can't split up a square root past the addition sign or subtraction sign. It just doesn't work. All right, so those don't work in general. Let's do a couple more for example A. So we'll do this example A, continue. A continued square root of negative 9 and negative square root of 9. I want you to think about those for a minute. Ryan C. What do you think about the first one?
Not a real.
Yeah, so it's not a real number, aka NARN. Good. And Nick, how about the next one?
-3.
Negative 3. Perfect. Thanks, gentlemen. Thanks. Sample B. A lot of your numbers aren't going to be nice, even perfect square roots. So in this one, I want you to round to 4 decimal places. Round to 4 decimals. So hopefully you're comfortable with your calculator. You take out your calculator, you take the square root, and you end up with 17.606816 dot 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 dot. And this dot 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 means it continues forever. The interesting thing here is that it's not going to have a pattern. It's just going to continue it forever. But I'm not worried about knowing all the digits. I'm just worried about knowing, say, the first 4. I want you to round to the 4th decimal digit. 4th decimal past the period here, or 4th digit past the period. So that's going to be approximately, and you're going to look at the first, you're going to look at the 5th position here and decide what you're going to do with this one. There's 2 possibilities. You either just chop everything off or you round up. Under what circumstance do you round up?
If it's over 5,
If it's over 5, what about if it's equal to 5?
then you round up.
Yeah, so if it's 5 or more, you're gonna round up. So, Hannah, what's this gonna be then?
An 8.
An 8, thank you. So 17.6068, nice. Now, before I get to the point of the next one, before we start working on example C in earnest, I gotta show you a reason that we need what we're gonna use. So you don't have to copy this down. It's not necessarily relevant. Well, it is relevant, but let me show you these first 2 examples. Suppose I have the square root of 5 squared. Well, what's 5 squared?
5.
25.
25. And then the square root is 5. I'm going to play that same game again, except instead of starting out with a positive 5, I'm going to start out with a negative 5. Let's see if that makes a difference. Negative 5 squared,
25.
25. And the square root is?
Plus or minus 5. It'd just be 5.
It'd just be a 5, because I didn't put the plus or minus out here, so I'd just be looking for the positive root there. But thank you, though. That's very conscientious to think about positive and negative roots there. So the reason I point that out is because you have to know and understand what to do when you have something like this. Square root of x squared. Now, everybody's probably in their head saying, it's x. Sort of. But here's the thing. If I start out with something positive, that's great. If I start out with 5, I end up with 5. But if I start out with negative 5, I end up with positive 5. And if I start out with if x is negative, I should end up with something positive here. I've got to make sure that that expression is always positive. How can I do that? How can I make sure that it's positive when I evaluate this or when I look at this expression? How can I guarantee that it's always positive?
Put a subtraction sign.
If I put a minus sign out here, then when I started with a positive 5, I'd end up with a negative 5.
Absolute value.
Absolute.
Yes, thank you, ladies. So the absolute value is going to make that term positive. So that's what we're looking for. So if you're following along with Mr. Robinson's advice, maybe you want to star that, circle that, or something like that in your notes, because we're going to need this. And it's the source of several points of credit on your next exam. You'll be given something like this. Assume all variables are unrestricted and use the absolute value when necessary. Use the absolute value when necessary. So what does he mean? Well, I mean something like this. Suppose you had the square root of 4y squared. With multiplication and division, you can split things up. So I'll split that up as the square root of 4 times the square root of y squared. The square root of 4, that's the easy part. That's just a 2. We don't need the plus or minus. There's no absolute value. It's just 2. But with a variable here, that's where things change. If you gave me 2y on an exam, I'm not sure I'm going to give you any credit. What does this need to be to get credit?
Absolute value.
Yeah, 2 times the absolute value of y. Perfect. Got to get that absolute value in there.
Would absolute value be the same as like plus and negative?
No, because the negative would just, take the opposite of this. The absolute value is going to always make it positive. So that's what we want out of this, is to guarantee that whatever expression comes out of here, it's positive. All right. Let's try another one. Square root of y squared minus 2y plus 1. I get stuff like this on exams all the time. And this is one of those things that I would say is a concept error based on what Mr. Robinson was saying. That is, a lot of students give me, and don't copy this down, please don't copy this down, y squared minus the square root of 2y plus the square root of 1, and then you simplify it down to y minus the square root of 2y plus 1. That would be very easy for me to grade, if you know what I mean. It's just really wrong. So, on the test you got back, one of the things you had to do was factor something like this. I think it was x squared plus 18x plus 81. But let's factor this. This is the friendly case of factorization because this has a coefficient of 1. What do I need out here? How's this going to factor?
Y minus 1, y minus 1.
Yeah, you need two numbers that multiply at a positive 1 and add a negative 1. So a y and a y. Both of these signs have to match this so that you have a negative times a negative is positive. And then a 1 and a 1. But if on a test you left it like this, I'd probably give you 2 points out of 3. There's one thing more that I'm expecting on this, and that is for you to write it like this, y minus 1 squared. And it's not until you write it as y minus 1 squared that you can actually finish simplifying this. Give yourself a second, see what you can come up with. How is that going to simplify? Any takers? Colby, I think I saw your hand first.
And it will just turn into absolute value sign y minus 1 and enclose absolute values.
Sterling, do you agree?
I was gonna say just a wide absolute value.
So it's a good question, and the answer, this is what I'd like. Just a quick FYI, you can't do anything more with the absolute value, so if you're tempted to say, oh, it's the absolute value of y minus 1, that's not true. Nor is it y minus the absolute value of 1, or any other combination. This is it. That's as far as you can go with that absolute value. In this sense, it's kind of like the square root. You can't distribute it or anything else. That's it. But you need to have written it as a squared in order to go that last step. So, all right, thanks, gentlemen. Why don't you try a similar one? Let's see. Let's do a squared minus 10a plus 25. You can't break up the square root from here, but you can simplify and work with what's underneath the radical. So, Ryan G, any luck in factoring this? So it has to start out with an A and an A, right?
Plus minus 25 and 1 or something? Yeah, you said, you did it to the.
So I need
to the
two things that
earlier.
multiply to 25 and add to.
Okay, yeah, that confused me a little since you did it to the 1y squared earlier.
So two things that multiply to 25 and add to negative 10.
Negative 5.
Negative 5 and negative 5. So rewrite that as the square root of a minus 5 squared. And thanks, Kyrene. And I think there's one other voice in there as well. Square root of a minus 5 squared is?
A minus 5.
Yes, well done. Absolute value a minus 5. Beautiful. You have to recognize how this factors in order to be able to get this one right. Okay, now we're not always going to be stuck with just square roots. Sometimes we're going to work with higher power roots. So let's talk about those. So still kind of cruising along, but we'll look at, for example, D. Let's start out with a very basic one, cube root of 8. So in the last example, even though I didn't really write it, it's understood that there's a 2 out front. It's the square root. So you're looking for something that you can square to get this. Or back with some of the other problems, what can I square to get 16? Again, there's a 2 that's understood to be out here. Now I've got a cube root. I'm looking for something that I can multiply by itself 3 times. So something times something times something gives me 8. Does anyone want to guess what that is in this case? 2. Now, if you're not a calculating machine, and I don't expect you to be so, then maybe you want to figure out how to do that on your calculator. So for the TI-84 and similar calculators, you're going to hit the math key. The 4th option down gives you roots like that. So I'll just type the number 4, or you can scroll down and press enter. Cube root of 8, and bam, 2. But here's where cube roots are going to be different than square roots. By the way, you can check this by calculating 2 cubed, which is 2 times 2 times 2, and that's 8. And that matches. What if I gave you the cube root of -8? Can I even do that? I mean, for square roots, we couldn't take a square root of a negative number.
You can.
Yes.
Ah, you can do the cube root of a negative number. Now, just kind of a FYI, when you're doing negative numbers, when you want to input a negative number, you have to use the minus key on the bottom, or the opposite key on the bottom row of your calculator. If you use the subtraction key, it's not going to like you. So, cube root of -8 is -2. And again, you can check it. -2 cubed is -2 times -2 times -2. 2 times 2 times 2 is 8. Positive, or excuse me, negative times a negative times a negative. You've got an odd number of negative signs. Odd number of negative signs, let me say that again. So you're going to get a negative product. Yay. Let's try a couple more in terms of the cube root variety. Let's try the cube root of 125 divided by 729. And let's also throw in something a little bit more exotic. Maybe let's do the cube root of 343 over 216. Now with each of these, what you might want to do is rewrite it as the cube root of, say, 125 over the cube root of 729, and work on these things individually. While you do that, I'm going to list out the first 10 perfect cubes. So do that on the right-hand side here. Let's see. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And does anyone tell me what 10 cubed is? 1,000. Nice. So it's helpful to be familiar with these things so that when you see them, that evokes the right response, that, oh, I'm dealing with a cube or I'm dealing with a square. But that's the way I would start. Pearl,
Yes.
how about this one? What's the cube root in the numerator?
5,
5 over
9.
9. Excellent. And Gustavo, let's do this next one. What are each of these cube roots?
7 over 6.
Nice, 7 over 6. Now, just kind of a FYI and reminder, you don't have to be a mathematical genius to be able to get these cube root problems right. Suppose you did math for, and let's do the last one, 343 divided by 216, and it's going to give you some kind of crazy number that you're not going to recognize, 1.18 something maybe, or 1.16. And you look at that, well, I don't know. Here's the trick. Hit the math key and press enter twice. Oh, 7.6. Perfect. Ian, you look like you like that one. It's like, oh, hey, that was just pretty nice. Yeah, that works out nice. So keep in mind that your calculator can help you on these. Except we're not going to always just stick with cube roots or square roots. There's a whole world of roots out there. Kind of depends on the problem that you're facing. So let's try some more roots. Some higher power roots. Starting with, we'll call this one example E. And that'd be the fourth root of 16. Now, instead of looking for something to the third power or second power, now we're looking for something that we can raise to the fourth power to give us 16. 4 is called the index of the radical or the power of the radical. What's that?
Oh, that's different.
Oh, yeah, the answer is 2. Good. But the thing is, you're not always going to be able to do these things in your head because the numbers are going to get bigger. So make sure you can do it on your calculator. So let me clear out a couple things here and show you how to do it on your calculator. On the TI, I would type in the number 4, then hit the math key. You don't want the fourth option down, you want the fifth option down. Notice it puts an X here for your radical. So type the fifth option down. So I want the fourth root of 16, and that should give me the 2. Now I'll walk around. Some of you have other calculators. If you have another calculator and need some help, let me know. Has everyone got everyone's got a TI? No, you might want to borrow one or something. Everyone's got a TI? All right. Yours is right here, I think. Let's see. Clear that out. Type in 4. And then second. 16. How about that? That's amazing. Yeah, you're gonna have to be self-sufficient on that one. By the way, you can't use this one on a test, because it's got the algebraic portion. Think, you good? All right. Okay, so let's try one other one, just to check yourself on this. Try the 6th root of 729. This should come out to a nice even number. So give that one a shot. Tell me what you get. And then we'll work on a couple more here. Lauren, how are we looking on this one? What'd you get?
I got 3.
3? All right. Everyone else getting 3?
Yeah.
All right, good, thank you. What if I gave you negative of the 5th root of 243? Or the 6th root of negative 64? So a couple more to think about here. Well, the first one is going to take a little bit of care in doing this. So there's really a few ways you can do this one. Kind of depends on you. But if you wanted to start out with a negative, you got to be careful because it's the way this thing works, it's going to want to put that negative up into the exponent. So if you do negative the 5th root of, and then hit the math key, and then option 5, it put that negative 5 up here. I don't want that negative 5 in the exponent. That's going to give me, or the power of the radical, it's going to give me something much different than I expect and want. So a safe way to do this is just to remember that there's a negative out front and add it in when you're all done. So I'll do, let's see, I'll do this one here. I'll type in the 5th root and then 243. And then remember, oh, I got a negative out front. That's going to be a negative 3. Nothing wrong with that way.
Quick question.
Yes.
Could you put in parentheses?
Yes.
Put a -1 outside?
So you don't even need to put the -1. You just put a negative outside in parentheses and then do your 5th root stuff. So 5 5th root of 243, and that'll work just fine. So So exit this, close your parenthesis, and perfect. In fact, I learned something new from one of my students this morning. Let's do this one last time. If you type in the 5th root and then your 243, your calculator will let you go back. And if you go over enough, it'll finally get out front of all this, and then you can put in your negative like that. So lots of options here for you. Bottom line, you should end up with a -3. But the one after that should have given you some problems. What happened when you tried to take, say, the 6th root of -64? Yeah, so 5, let's see, 6th root of -64. This is, let's see, I keep on forgetting to change my mode. You should end up with something like this. That is, you're not getting a real answer. No real answer, not a real number, all the same thing. So this one really essentially is NARN. Is the correct answer here. I'm going to shorten something up here in the interest of time. And we've already seen some of this, so I'm not really cheating you much. Just not giving you as much buildup as I might otherwise. A lot of times you're going to run into the expression, or an expression something like this. The nth root of y to the n. And there's two possibilities. The first possibility is that's going to equal y if n is odd. So for instance, if you had, say, the cube root of a cubed is just a. It's going to equal the absolute value of y. Any guesses?
It's even.
If n is even. So if I had the 4th root of b to the 4th power, that would give me the absolute value of b. So the big thing to remember is that if these things match, and only if they match, then you're going to start thinking about this. All right. 2 problems for you. The 8th root of t to the 8th. And let's do the 11th root of z to the 11th power. Try and simplify each of those. Sarah, what'd you get for the first one, please? Absolute value of t. Good. Jessica? Jocelyn? What'd you get for the second one?
You would just put Z.
Yeah, just z. The thing that I'm trying to highlight here is that this one's odd. You don't need the absolute value. This one's even. When they match and they're even, you need the absolute value. When they match and they're odd, you don't need the absolute value. Nice. So what if I extended that to a problem like, say, the 6th root of 729, h to the 6th power? Okay. I would break that up as the 6th root of 729 times the 6th root of h to the 6th. And then simplify from there. Let me give you a similar one to chew on. Let's see. Maybe 2 to chew on. 5th root of -243. Let's do d to the 5th power. and then fourth root of 16 r to the fourth power. So a couple more to chew on. While you're looking at that, I'm going to open up something in Desmos. All right. So with this first one, I would expect that you take your calculator out, unless you have these memorized. 6 root of 729 is going to be 3. What about the h here? What should I put for the h, John?
Absolute value of h.
Yeah, absolute value of h. Nice. Nice. Again, we're going to keep on splitting these things up. 5th root of negative 243 and the 5th root of d. Likewise down here, 4th root of 16, 4th root of r to the 4th. Let's see. What's the 5th root of negative 243? Negative 3. Do I need the absolute value around the d? No. Nice. How about the next one? What's the answer on that one?
2 and then absolute value r.
2 times the absolute value of r. Notice I don't have the absolute value around the 2. I don't need it around the 2, just around the r, please. But looking great. Looking great. All right, one last little thing to touch on before we finish up with this section, and that is a little bit of reworking or another visit to domain and range. So our last set of examples, example G. And what I want to remind you of, or maybe just tell you, because I don't expect that you really know this one off the top of your head, is the graph of the square root function. So the graph of the square root function is really going to look like a sideways parabola, or at least the top half of a sideways parabola. So it's going to start right here and go up like that. So you're going to have points, say, at 0, 0, 1 and 1, 4 and 2, and out here someplace, 9 and 3. So that's, roughly speaking, how the graph would look. Let's remind ourselves of domain and range. Domain was associated with what value? X's or Y's? X's. And let's think about the kinds of things you can put in for X. You can't put in just anything. What would be an example of something you can't put in for X?
0.
0. Well, let's see. Can you take the square root of 0?
Yes. Or
Yeah, you can take the square root of 0.
1.
The square root of 1 works. Negative. You can't put in any negative numbers. So our domain has to be things that are greater than or equal to 0. And you can see that visually. So the domain is, let's see, where's my, here we go. The domain is going to be everything this way. That's our domain. So in interval notation, that would be 0 to infinity. Inclusive of 0, infinity gets a parenthesis. Let's see. And that makes sense. You can only take square roots of positive things. The range is your y values. So the range, that's going to start from here and work up. So what's the range going to be? What's the smallest value that this function gets down to?
0.
0. And it goes up to infinity. So the range and the domain are the same. What if I looked at, for instance, y equals the square root of x plus 3? How's that going to affect the graph here?
That would be up. Let's start up.
Yeah, it's going to start by being shifted up by 3. So this point is at 0, 3. So the domain is still going to be the same. It's still going to be 0 to infinity. But what about the range of this function? 3 to infinity. Nice. Let's keep in mind what we did with domain and range there and find the domain of this function, h of x equals the square root of 24 minus 8x. What's nice is that with these functions, especially if you graph them, you can kind of see a nice correspondence between domain and range. Domain, there's your x values, range is your y values. But I don't always want to graph things. I will with this one, but let's think about what has to happen underneath here. We want to make sure 24 minus 8x is greater than or equal to what number? What's the minimum that I can take the square root of? 0. Okay. So I'll subtract 24 from both sides and get 8x is greater than or equal to negative 24. How do I finish solving here? How do I get x by itself?
Divided by -8.
Awesome. We're going to divide both sides by -8 and get x is less than or equal to 3. That's our domain. Now it's easy enough to see that, working it through, but if you had access to your graphing calculator, or even better yet, Desmos, let's do SQRT is a quick way to get up the square root, and do 24 minus 8x. Take a look at our graph. Let's see, come on. There we go. Where's your graph start? It starts at 3 and goes to the left. That's exactly what our domain is. It's negative infinity to 3 with a bracket there, because you're including the 3. You can take the square root when you plug in a 3 into this function. Beautiful. Any last minute comments or thoughts on this last one? That one's kind of a friendly one. If I ask you for the domain, you don't have to worry about the graph at all. You can just do it algebraically. You want to make sure that this expression right here, whatever it is greater than or equal to 0. And then you solve, and you're done. Mel, did you have a question?
I'm just gonna scroll a little bit.
Oh, sure.
It's the graph.
Oh, the graph? The graph was on a different page. Let me click over. Oh, all right. Yeah. I'll get that in a second. Anything else on this last one? Okay, let's put this one in the books.